Hello everyone, this is Kyle Welch with RCI Wireless News. I want to thank everyone for attending today's webinar, Progressing NFV to Carrier Grade Deployment, presented by Ixia. Our presenters today are Michael Haugh, Product Marketing Director at Exia, and Charles Ashton, Senior Director of Business Development at Wind River. At this time, I'd like to pass the presentation over to Michael.
Great, thank you very much, Kyle, and thank you to everyone who's attending live and attending our recorded session here. And I'd like to thank Charlie from Wind River for joining us in this session. So it's an exciting time in technology, and we're moving towards deployments of NFV. And what we'd like to take a look at in this webinar is, what does it really take to get NFV to a carrier-grade deployment? And so those are the things we're going to look at in this session. And so first and foremost, what are the drivers for using this technology in a service provider cloud and enabling services on top of it? Well, first and foremost, over the last 10 years or so, cloud technologies have really been transformative. When you look at software as a service with companies like Netflix enabling video streaming and changing the way video is delivered, to the tools we use for our businesses like Concur for expenses and Salesforce for contact management, and even our mail servers have moved to the cloud with tools like Office 365. So almost everywhere you turn now, one way or another, you're using software that's running in a cloud. And it enables you as a consumer of the technology to have a lower cost solution, and enables the provider to offer a very scalable, very effective solution for the end user. So what's transforming there as well is more and more now, the cloud providers themselves, so your Amazons and Rackspace, Microsoft, have been leveraging these cloud technology and actually enabling folks to actually use the compute and storage and networking resources directly. So this is referred to as infrastructure as a service or platform as a service. So these are some of the ways you consume cloud technologies today. What the carriers are looking at is they want to benefit from these technologies of cloud, which is economies of scale, lower cost, commoditized hardware, and really be able to leverage that for the services they're running. So one of the key drivers here is, by being able to run on a cloud infrastructure, is to reduce CapEx and OpEx spend, enable service agility, meaning the ability to spin up a service quickly or change a service quickly, as well as aligning capacity and cost to revenue. The carriers are kind of in an endless cycle where roughly every 5 years or so, they have to refresh the network. So there's a significant CapEx spend. They're testing and evaluating the next generation of routers and switches and products for the network. And then they have to deploy that network, doing capacity planning for at least 5 years or so while the usage grows into that model. So they're continually having to kind of outpace and outspend growth. And that's a painful situation for them, especially as more things are now running over the top, and they're seeing decreasing revenue per user and having to offer them more bandwidth. And they really want a simplified management of a multi-vendor network. So that, this is the vision of what cloud could provide. So the other key driver here is not just cost savings, but really the ability to drive new revenue, drive new services, so the carriers are not relegated to being a bandwidth provider. Being able to provide intelligent and sophisticated networks as a service or virtual functions as a service, be able to handle dynamic moves, adds, changes, so when customers want a service, it doesn't take the 30 or 60 days to get a service installed and instantiated and running, as well as brand new services we haven't even been able to see yet, which are location-based or being able to optimize the network to the application. And so this transformation is really defining a cloud that is really oriented around the telecommunications providers themselves. So this is the telco cloud. It's a different use case than just running applications in the cloud. So this vision for leveraging the cloud for network functions really started in 2012 when about a dozen or so service providers got together and wrote a white paper. And essentially was the initial requirements of what they're asking for. So they're putting this out there to say, hey vendors, if you actually build this and enable this, we will invest, we will build, and we will migrate to this next generation infrastructure. So through that, the work of the ETSI, and they started the study group for NFV in 2012 with over 220 participating companies now, and these are largely led by the carrier community. But the vision here is to take classical network functions, routers, firewalls, provider edge, BRAS, and instead of running them on classical appliances, move them and run them as virtual appliances on a common infrastructure that can be orchestrated and automated, and that's high volume. And so the trend here is to move away as much as possible from the physical appliance approach and run them in software. And you can go to the etsy.org/NFV page for a lot of information on that. In fact, the NFV ISG has completed phase 1 and now is into phase 2 and have over 17 specifications posted. Let's dive into this technology a little bit further because it's really fundamental to understand virtualization before you can understand cloud, and therefore before you can understand network function virtualization. So just when you look at compute and running an application, you have the bare metal compute infrastructure with CPU, memory, network interface cards, and storage. And then you're typically running on the Intel x86 architecture, and you run an operating system on that, and then on top of that you run one or more applications. And so as you look at enabling virtualization, what it really means is an installation of a virtualization layer, which is referred to as a hypervisor. Once that virtualization layer is in place, you can run one or more virtual machines on top of that common hardware. So it literally enables you to virtualize your compute, your network, your storage. And so each instance or virtual machine views that it's running completely independently. And with virtualization comes a lot of benefit, because once you can run this way, you can abstract away from the hardware, you can isolate issues or problems, it can be very dynamic. Most hypervisors support advanced functions that allow you to scale resources, do hot adds of memory or additional CPU on the fly. And when you look at the carrier needs, a lot of the virtualization layers out there, hypervisors and infrastructures, support carrier class needs, which include portability, and this is the ability to move a VM from one machine to another. It needs performance, and so we're going to dive into that bullet point for sure. You need elasticity, so the ability to kind of change the service as alignment to need with the needs of the end user. And so this has to do with being able to move a VM onto a machine with more resource, being able to dynamically change the resources allocated to the machine on the fly. There's also resiliency and security requirements, high availability requirements when you look at being able to monitor a VM and move it or restart it if there's an issue, fault tolerance if you are looking at having active and passive systems and be able to transfer between them. So going to virtualization and leveraging the technology that is available today that's built for cloud is what carriers are looking to build on top of. So let's move on to the ETSI reference model for NFV. So this is where it gets quite a bit more complex, and most of you who've looked at NFV have seen this diagram quite a bit. So I want to break down a few of these components to just kind of level set. So first and foremost, things are built on top of the NFV-I, or the NFV infrastructure, which is made up of that compute, storage, and hardware network with the virtualization layer installed, and then your virtual computer VM running on top. And so this is typically x86-based servers. You need high quality and high speed network interface cards. The selection of the network interface card is actually quite important because you may require DPDK support. So we'll talk a little bit more about DPDK, but it's a technology for speeding up packet processing and packet handling, and only specific NIC cards support that. When you look at the hypervisor itself, VMware is a leader in this space with ESXi. However, it's really more built around enterprise requirements, and is not really at this point built for network function virtualization. It's also a bit expensive from a software licensing standpoint. So a lot of the carriers are looking to leverage technology built on open source like Linux. And so KVM, it's a hypervisor developed originally by Red Hat, which uses processor extensions from Intel and AMD, which allow it to run and enable virtual machines to run on top of a common compute. So KVM is becoming the kind of go-to hypervisor out there. When you look at the virtual networking, this is where also a very critical component, and this is where SDN becomes into play, because once you start building virtual machines, you need to have networking technology to connect them to other virtual machines, as well as connect to physical network functions in terms of transitioning from physical to virtual. And so SDN is a technology here that, if you look at the Open vSwitch, which is a component now of most Linux distributions, it's an SDN-enabled vSwitch, and that allows you to program the network layer and configure the connectivity that's required. There's quite a few networking options, but Open vSwitch, being an open standard and coming with Linux, is gaining a lot of popularity. But again, oftentimes, regardless if you use Open vSwitch or not, the virtual networking technology you're using oftentimes is now SDN enabled for programming of the network. As you move over to the box on the right, this block is called the Management and Orchestration, or MANO. And one of the key components here is the Virtual Infrastructure Manager, or VIM for short. And OpenStack, as being a cloud operating system, has become kind of the de facto standard out there for virtual machine management. It allows you to manage across hundreds or thousands of compute nodes and handle things like the VM provisioning, configuring of the network layer with the Neutron plugin. And it really is a dynamic piece of software that provides APIs, or programmatic interfaces, into your compute and into your networking. And OpenStack very quickly is adding and getting features that are required by carriers for NFV. I'll give an example coming up here with the OpenStack Kilo release, adding a feature called Enhanced Platform Awareness. And so we're going to talk about that in a slide or two. When you look at the actual VMs, or VNFs, or virtual network functions, nearly all major vendors out there today, from Cisco, Juniper, Alcatel-Lucent, Huawei, the list goes on as you look at security and load balancing, and even into the wireless space, vendors like Ericsson. Essentially all vendors are creating virtualized versions of their functions. And so this is very quickly becoming a robust marketplace. However, the VNFs themselves have to be qualified on top of the hypervisor, on top of the compute, qualified for performance, and it is actually quite an undertaking for the vendors to provide virtual versions that have been fully tested and qualified. So the upper right side here of MANO involves 2 to 3 other really critical components. One is the NFV orchestrator. This has the responsibility of kind of lifecycle management. Then you have a component called the VNF manager themselves, so the items that actually manage each VNF. This box is in red for a particular reason, because this is where there's still a lot of work to be done. The MANO spec actually just came out at the end of 2014 from the ETSI group. And the challenging part here is clearly defining the roles and responsibilities of things like the orchestrator and the VNF manager, and having more of a common language to talk down to your VNFs in terms of initializing, configuring, state management. And so there's efforts going on in terms of how to share information, how to do information modeling, and how to define a VNF like descriptor and a service descriptor. And so some areas of work going on are the Yang modeling is being, or Yang and XML are being used to define VNFs and their capabilities. So those modeling languages are very useful for defining individual components and their features. And then there's a modeling language called Tosca, which Tosca defines services and components and their relationships. So Tosca is an effective modeling language for orchestrators to use. So this is where, when we talk about NFV getting to carrier grade, you need to have scale, you need to have lifecycle management, and you need to be able to integrate the OSS and BSS for billing and the active management of the VNFs themselves. And so this is where probably the most work is going on right now, and there's a lot of companies working in this space providing early solutions that are working well. So again, there's been great progress made, but again, this is a kind of key area that is progressing. And a challenge related to this is that communication providers are looking to leverage existing OSS BSS. They don't kind of want to build out new from scratch. So when you look at leveraging existing OSS and BSS, you need to then integrate into the new orchestrators. And so that puts again a challenge on the orchestration component, which is integrating into a legacy OSS BSS. And so this is again one of the elements that's kind of slowing down some of the carrier deployments. So moving ahead here, what are the key drivers that carriers are looking at? A few years back, it was clearly around cost savings. Now, in a recent poll, this actually just came out in May from Analysis Mason, is that 80% of the carriers queried said it's about new services. So it's service-led and revenue-led, new revenue-generating services. It's only 15% driver is really just kind of converting the infrastructure from physical to virtual, kind of moving, kind of platform shifting. And then only 5% really are looking at it as kind of moving, telecom, traditional telecom to IT-like technology. So I think the interesting point here is that most carriers out there are looking at ways to develop new businesses and new services. And where are we at today with those deployments? Well, first, when this technology really was coming about, there was some low-hanging fruit. There's things like DNS and DHCP, which can run in software already. So those things were moved to running on virtualized services and existing clouds and data centers the service providers had access to. When you begin to look at what happened towards the end of 2014 and through 2015, it's really been the year of trials. There's more than 30 ETSI guided trials that have POCs that have been completed, and quite a few are progressing. There's been quite a few early deployments, and when you look at these, the use cases are kind of isolated to single function, like virtualizing the BRAS for broadband subscribers, virtualizing the CPE to enable more dynamic services for customer prem or broadband services, beginning to virtualize the EPC or IMS when looking at rolling those things out. So when carriers have moved to this, it's because they can invest in, where they're usually needing to build out a bit to have these capabilities in the network. Looking at 2016, 2017, it's about more complex use cases, adding in, dropping in firewalls dynamically, intrusion detection, load balancing. So the use cases are getting broader as well as more complicated. A quick snapshot of some carrier and vendor activity in the space. I just want to bring out that like two leading vendors out there from a compute and solution standpoint with Alcatel-Lucent's Cloudband ecosystem as well as HP's OP-NFV. They're fairly similar in the numbers they've talked about, which is around 25 plus projects out there. Then you have major carriers like AT&T stating they're targeting 75% of the network using cloud infrastructure by 2020, and companies like Telefonica saying 30% of their network will be virtual by 2017. So you can see across the board, really in almost every major geo, carriers are enabling early deployments and trials and looking at rolling this out. So what's another one of the main challenges is the fact that when you look at running network function virtualization, you can't just take a virtual router and deploy it in the cloud and expect to get good performance. There's an excellent paper produced by Intel, Brocade, Cyan, who was acquired by Ciena and Red Hat, and it was run in the Telefonica lab. Telefonica produced the performance and portability paper for the ETSI. And they're stating, look, if you just deploy a service in a IT cloud, you're going to actually get very poor performance, and it's not going to be predictable. And the reason is that you need to understand the data plane and the workload and how that workload is affected on the underlying compute. You need to be aware of the underlying features, which we're going to talk about in a bit. But in this comparison, running routed infrastructure, by just dropping the routed infrastructure on the IT cloud, they only got 270,000 packets per second, whereas by running in a platform-aware, discretely deploying it with known configuration, they're able to achieve 23 million packet per second. So that's they got 40 gigabit throughput. So this is a really key aspect, is that when you look at the carrier requirement, they need to understand the underlying infrastructure. And there's a feature coming out that's available from Intel and exposed in OpenStack Kilo, which is called Enhanced Platform Awareness, which exposes these things. So when we look at testing these things, in a traditional environment, you connect a tester to a physical device, and that device is purpose-built. So it's predictable, it gets consistent performance, there's limited variables. When you move over to a virtual environment and you just connect the tester to the physical side and do bottoms-up testing, there are a lot more variables, and that's what we're talking about with having platform awareness, where you understand the NIC and its capabilities, the hypervisor and its settings, the vSwitch and how it's forwarding, and being able to test bottoms up, understanding the physical components, and then actually injecting testing into the virtual space and testing top down. So I want to dive into a couple of these things to be aware of, and this is what are kind of the bottlenecks that affect performance. So one of the most effective is understanding the QPI bus as well as NUMA boundaries. And so if I deploy a virtual router, I want to know what cores on which processor slot they're assigned. Because what will happen is if I assign a router to core on slot 0 and cores on slot 1, then I will be crossing a NUMA boundary, and because the processor will be trying to access memory across the NUMA boundary, and that's a problem. The other issue is that with the PCI assignments, these green links off the processors, you have PCI slot assignment for your network adapters going to specific processors. And so if I'm trying to move traffic from a PCI connected a NIC on processor 1 over to a NIC on processor 2, I'm going to be crossing that QPI bottleneck, and it's a definite performance killer. A few other things to highlight is that on the compute platform themselves, virtualization technology must be enabled in the BIOS for it to run. Logical processor can be enabled using hyperthreading. And I mentioned DPDK as an acceleration technology to move packets much faster through the system. And again, DPDK requires NICs that support it. So run through a couple other quick things is sometimes to get the best performance out of a virtual machine, PCI pass-through is used. And so you can either use a direct assignment where your VNF talks directly to the NIC, or a technology called SR-IOV, which is allows a VNF to talk directly to the NIC through an interface. And these are great for just direct performance of the VNF, but there's some problems with it as well. One is that you bypass the vSwitch in these environments, and if you're using that vSwitch for your networking connectivity, it can be a problem, as well as the VNF requires specific drivers for that NIC, and then there's going to be other limitations. And so where you might choose something for performance, it may end up degrading your overall capacity or ability to deliver the service. So how does Ixia fit into this? I want to just, like 2 quick slides on where we fit. Is that first, we're used in the QA environments where we always have been in terms of the testing and does it scale. Through acquisition, we've moved into the monitoring space with the packet broker solution and TAPS with Anui and NetOptics acquisitions. And so we can actually move out into the network and enhance and optimize monitoring tools. The newer technologies we've enabled, actually starting back in '09, but over the last years we've made more of an investment in this area, is that our key test solutions for layer 2, layer 3 with IX Network, layer 4, layer 7 with IX Load, and security with Breaking Point have all been virtualized. And so now these technologies can run as virtual machines and help test in the virtual environments. From the monitoring side, we have a lightweight software endpoint called IX Chariot, and IX Chariot can be used to test performance end-to-end. So this is more like service chaining and end-to-end verification. And then finally, through our tapping technology, we developed a virtual tap. The Phantom Virtual Tap allows you to tap into see VM to VM traffic that otherwise may not hit the wire. So a cool piece of innovation. So kind of in summary here, as you look at the Exia technologies across network, load, breaking point, chariot, they can be applied to the physical side, testing bottoms up, as well as deployed virtually, testing top down, and being virtualized themselves, that can be used and orchestrated with technologies like OpenStack. A very quick example of a deployment scenario here, where you use your orchestrator to deploy your virtual network functions. The orchestration, let's say OpenStack talks to a network controller through the Neutron plugin. The network controller provisions a path end-to-end. So now you have your VNFs, you have your networking technology. Now you need to verify this service actually works. You can deploy or spin up test technology like Ixia's IX Chariot and validate the service end-to-end. And so more and more technologies are being built into the orchestration engines, are coordinated to do service activation testing. So last slide for me is that, so how do you move to actually get to testing and deployment? Well, there's a few reference platforms out there. One of the more well-known one now is called OPNFV, Open Platform for NFV, focused on the NFV-I, so it's based on open source components. Another one out there that you may be aware of is Intel has released Intel's ONP. And again, it's a reference architecture that is actually downloadable code based on open source. And these platforms will give you the ability to get running today and actually begin to play with this technology. Challenge is how do you go from open source and reference to carrier grade deployments? And that's where Wind River comes in. And so with that, I'd like to turn it over to Charlie to introduce the Titanium server and a carrier grade deployment or carrier grade platform for NFV. So for more information on Ixia, you can check out ixiacom.com/NFV. We have a great ebook and a performance paper on NFV. So with that, Charlie, all yours.
Well, thank you very much, Mike. Certainly appreciate the opportunity for Wind River to be part of this webinar. And thanks for that very good introduction to overall what's going on within NFV and some of the challenges, as you mentioned, that are important, such as, how do you move to a real carrier-grade deployment? So what I'm going to talk about in probably about 20 minutes here is I'll just give everybody a quick introduction to Wind River's role in NFV, which is one of the several markets that Wind River actually targets. Then we'll talk about some of the real business drivers for carrier-grade NFV platforms. We'll also talk about some of the things you have to do to minimize the risks associated with virtualization. And then we'll quickly touch on Wind River's solution, which, as Mike mentioned, is called Titanium Server, as well as the whole end-to-end ecosystem that we have put in place around that, which is called Titanium Cloud. And then we'll just summarize and talk about some of the key benefits that this brings, both to the TEMs, to the telecom equipment manufacturers, and also to the service providers. So first of all, I thought I would just do a quick introduction to Wind River in NFV specifically, because Wind River has actually been around since 1981. Many of you may remember Wind River from many years ago. The company was founded with a focus on embedded tools and operating systems. Products like VxWorks and Tornado go way back many, many years. Wind River did an IPO in 1993 and actually was acquired by Intel in 2009. So today we're a wholly owned subsidiary of Intel. Our software has been deployed in over 2 billion devices, not only worldwide, but also on some other worlds. As you can see here, the picture of the Mars rover. We're very proud that that's running the Wind River operating system. But basically, our software goes into environments and systems and applications that are subject to the highest standards of safety, security, and performance. We have a leadership position in embedded solutions. The most recent industry analysis that I saw that Wind River has 40% market share and has by far the industry's broadest product portfolio. And I think what's relevant to the discussion today is that our customers in telecom, which is a major focus market for us, today they include all of the top 20 telecom equipment manufacturers around the world. So in terms of NFV, our whole focus is to solve some very critical challenges, and these are challenges that Mike mentioned in his presentation. So through Titanium Server, we provide the only commercial NFV cloud that delivers the true carrier-grade reliability that's required for telecom networks. And as I mentioned, this is all supported by the ecosystem that we call Titanium Cloud, which is supported by a number of industry-leading partners, such as our friends at Exia. But let's talk about some of the business drivers for why you have to have carrier-grade reliability in these NFV platforms. There was a very interesting study that was published about 18 months ago by Heavy Reading. And they took a look at the situation today, and they concluded that even with today's traditional physical infrastructure, which is very well matured, very stable, network outages are still causing major revenue impacts for service providers. And when they analyzed this, they figured out that worldwide, network outages are costing $15 billion per year in terms of revenue impact to the service providers. And this is anywhere from 1% to 5% of their revenues. The impacts really come through three things. First of all, they come through customer churn. In other words, the cost of reacquiring customers that you lose because of network outages, plus the significant operational expenses that the carriers have to incur in order to fix the problems. And then finally, through service level agreement penalties. Most of the service providers have very stringent SLAs with their enterprise customers. And if the network downtime exceeds a certain threshold, then they have to pay very significant penalties out to those customers. That's a big component of this $15 billion a year hit that the service providers are taking today. Now, NFV actually has the potential to make this a lot worse. You have to remember that traditional physical infrastructure typically delivers 6 nines reliability. In other words, 99.9999% uptime for the network infrastructure. And this reliability has been developed and proven over many, many years and many thousands of deployments, both of the services and the infrastructure. As Mike described, NFV actually adds significant risk factors here because now we have applications that are brand new and they're virtualized. We can dynamically reallocate our virtual machines across servers and across racks and across data centers, which means we really have no idea what's running where. And the traffic flows are very complex and very hard to debug. So it becomes very important to implement true carrier-grade reliability into NFV deployments because there's a very significant risk to the service provider's revenue if you're not able to maintain the uptime as they transition to NFV. And this is really the critical challenge that we at Wind River address with our Titanium Server solution. So this is just an example of some of the factors which service providers think about when they look at key performance metrics and key features that are required in telecom infrastructure. And when you look at this kind of analysis, you conclude very quickly that enterprise IT platforms just do not deliver the capabilities that are required for telecom infrastructure. You have to have platforms that are specially designed with the right features and the right performance to meet the carrier-grade requirements that the service providers have. It's also very important as the service providers think about how they transition to NFV that they look at some of the risk factors associated with virtualization. And Mike did a very good job of explaining some of the key concepts that play into this whole use of virtualization in the carrier space. But there's some very significant risks that have to be considered as you start to use virtualization for NFV. You have to think about things like, does your application have real-time performance constraints? Because, you know, not all hypervisor platforms really provide the kind of deterministic low latency interrupt response that you need. You have to think about, is your application really sufficiently abstracted from the hardware? Because if your application has tightly coupled dependencies to the hardware, then those are going to be very problematic for virtualization. You have to have a virtualization strategy that takes into account the storage and the networking and the compute nodes. And you need to choose, you know, the right deployment model and very precisely define the requirements here. You have to look at the situation with your legacy applications. I mean, do they need to run unmodified when they're virtualized? Because typically, you do need to make some minor changes to the applications so that you can ensure a smooth transition from a physical implementation to a virtual implementation. You have to look at whether a virtualized implementation can actually meet your critical performance requirements. Because standard open source hypervisors, standard vSwitches, they may not deliver the kind of low latency or the high packet throughput that you're going to need in a virtualized telecom environment. And finally, and very important, you have to look at whether there's a complete software ecosystem that's been validated to work with your hypervisor platform, because if not, you may be stuck with a hybrid solution, and that's certainly going to be suboptimal. So we address these problems through this solution called Titanium Server, which really is a critical infrastructure platform for NFV. At a high level, Titanium Server is an application-ready software platform that runs the virtual functions with full carrier-grade reliability. And while it's doing this, it's also accelerating the performance of the VNFs, which is important in terms of maximizing CapEx and OpEx savings for the service provider. It's fully compatible with all of the relevant APIs that Mike talked about earlier. And very importantly, it hosts any guest OS. So the service providers have the maximum amount of flexibility in terms of the VNFs that they can choose, because there's no restriction as to which OS that VNF has to run on. And as I mentioned, this is supported by the Titanium Cloud ecosystem of validated hardware and software products coming from our partners like Exia. So in terms of what this looks like in terms of the system architecture, Titanium Server essentially provides the storage nodes, the compute nodes, and the control nodes that you need within that NFV-I layer that Mike highlighted in the overall ETSI diagram. And then the compute node is where the virtual machines or the virtual network functions are actually running. And their performance is accelerated by the accelerated vSwitch that we have. And all of this runs on the compute platform itself. So this is kind of the system level architecture view of where Titanium Server sits. It's probably worth spending just a couple of minutes on the actual architecture of Titanium Server, because I think it's important to understand how it's based on open source technologies together with some critical enhancements. So Titanium Server is absolutely based on standard open source components. As it shows here in the diagram, it's based on OpenStack, based on carrier-grade Linux, the KVM hypervisor, and Ceph storage. And then what our experts have done is they've added critical features to this foundation in order to meet the needs of carrier-grade networks. So we add critical real-time performance enhancements to KVM so that we can address some of those virtualization performance issues that I talked about a minute ago. We add a carrier-grade accelerated vSwitch. This is based on the Intel VPDK library that Mike talked about, and it delivers high performance, high bandwidth to the virtual machines, while at the same time supporting all of the critical features that you need for carrier-grade reliability and telecom security. On top of OpenStack, we add a large range of carrier-grade cloud management functions and telco middleware functions. And all of these are implemented as plugins to OpenStack, which allows us to then take advantage of new versions of OpenStack as they come along. We can just reapply the plugins once those new versions of OpenStack are stable. And then finally, we add a carrier-grade storage cluster, which can run either centralized or local, depending on the requirements the service provider has. And then very importantly, as I mentioned earlier, Titanium Server can host any guest operating system, which maximizes the flexibility that the service providers have when they choose their VNFs. So all this is fully compatible with the ETSI standards. If we come back to the picture that Mike showed earlier, Titanium Server contains an optional VNF manager. It's optional because if the VNF itself comes with its own VNF manager, you can use that one. But if it doesn't, then you can use the one that's present in Titanium Server. It has the Virtualized Infrastructure Manager, or the VIN, and then it has the complete NFV-I infrastructure software layer, as we saw on the previous diagram. So what does all this mean in terms of actually delivering carrier-grade reliability? Well, there's a number of very complex features and capabilities that you actually have to have in order to really meet the service provider's requirements for carrier grade. You have to be able to do high-performance live migration of VMs, including VMs that are based on DPDK themselves. You have to have minimum latency for the virtualized applications. You have to be able to automatically recover failed VMs and failed controllers and failed hosts. You have to have carrier class software management. This means things like automated installation and commissioning of your cloud software. And you need to be able to do hitless patching and upgrades with full support for rollbacks. You have to have high performance switching for the VM to VM traffic. You have to have very sophisticated scale up and scale down schemes for the VMs with very advanced resource monitoring. You have to have full telecom grade security, which means not only supporting, authentication, authorization, and accounting, which is the standard AAA security, but you also have to be able to do VM isolation and full QoS. And then you have to have carrier-grade scalable storage. And so all of these features and capabilities are delivered through Titanium Server, and that's what allows the service providers to deploy infrastructure that maintains the 6 nines reliability that is so critical to their business, as we talked about earlier. So if we come back to that original chart where we showed that enterprise IT platforms fall way short in terms of meeting the requirements for carrier-grade telecom infrastructure, when we fill in another column here and we show what Titanium Server delivers, it either meets or exceeds the requirements of telecom infrastructure in all of these, all of these categories that we've shown here as very important examples. So let's talk a little bit about the Titanium Cloud ecosystem. Titanium Cloud is not a marketing program. It's very important technical collaboration that we do with vendors of complementary NFV products. So we launched this program in June of 2014. We had 5 partners at launch time. We have 23 partners today, including Exia. And this program involves very in-depth engineering collaboration so that we work with our partners and make sure that their applications and their hardware, in the case of the server guys, not only work correctly with Titanium Server, but also are optimized in whatever ways make sense to take full advantage of the features and the capabilities of Titanium Server. So there's a lot of very detailed engineering collaboration that goes on here, plus the kind of joint marketing that makes sense so that we can actually end up with winning business together at customers that we're targeting. So today, this is a set of partners that we have within the Titanium Cloud ecosystem. You can see that by far the largest number of partners is in the virtual network function or VNF category, and I would expect that to continue because one of the things that we're seeing with NFV is that thanks to the open standards, a large number of software companies are now being encouraged and being able to enter the telecom market with VNFs that are tuned and optimized for very specific use cases. So I would expect that to always be the largest category. And then, of course, the other categories where we have partners are the OSS BSS, the NFV orchestration solutions, and the actual hardware server platforms that all of the software ends up running on. I think it's interesting to reflect just some of the lessons that we've learned, a year now after launching this program, because we actually got some surprises during the last year as we've made progress with the program. The first thing that we've learned, and I'm sure that Mike could confirm this from the experience that we've had together, is partner product validations are very complex technical programs, and they certainly require solid engineering commitments on both sides. From our perspective, we have a technical team now that's dedicated to supporting partner validations. That's all those guys do. And it's really important when you enter into a validation program with a partner that you have comprehensive test plans, very good documentation, and comprehensive reporting at the end. The other thing that we found from our point of view is partners are really excellent beta sites. In many ways for us, they stress our product harder than regular customers do, and certainly earlier than regular customers do. And the reason is they're trying to fully leverage the features and performance optimizations of Titanium Server so that they can have the best possible differentiation in their product, and then they can be successful, as we target joint customers. But the bottom line is this kind of a program has massive benefits for both parties. Because the service providers, they really want proven end-to-end solutions. They're not terribly interested in point products and then having to put together the end solution themselves. They want a proven end-to-end solution. And this kind of program accelerates the service provider deployments. It also minimizes their schedule risk because they don't have to worry about doing the integration themselves and making sure that everything works together if we've done the pre-validation ahead of time with our key partners. So some of the example NFV use cases that we have partnerships around, this is by no means a complete list, but things like virtual firewalls, virtual routers, virtual session border controllers or SBCs, and of course, as Mike talked about earlier, virtual test and measurement tools. So just as a couple of examples of the partnerships that we have for virtual firewalls, we have a partnership with Intel Security, and at many conferences we've demonstrated their virtual next generation firewall running on Titanium Server. Similarly, we have a partnership with Brocade around virtual routing. And again, there's been several events where we've demonstrated the performance of Brocade's virtual router running on the Titanium Server infrastructure. This was also part of a joint ETSI proof of concept that we did. Just recently, Genband announced that they had ported their virtual session border controller to Titanium Server. We did a joint demo with them at the Intel Developer Forum event last month in San Francisco. And last but by no means least, we have the partnership with Exia. And as Mike mentioned earlier, they've ported now both their virtual network test tools and their virtual application test tools to run on Titanium Server. And so these are used throughout service provider networks. They provide very comprehensive testing and performance measurement of virtualized network infrastructure and also the virtualized applications. And through their two platforms here, they cover all the way from layer 2-3 up to layer 4-7. And basically, they can test VNS for functionality, performance, and scalability. They can also orchestrate the deployment of virtual test ports and all of the networking that goes along with that. So we've seen a ton of customer interest in running the Ixia tools on Titanium Server, and that continues to go very well. So just a quick summary then of what we've talked about here in the last few minutes. So first of all, we talked about the fact that NFV should enable service providers to address critical challenges. And these are challenges such as reducing OpEx, increasing their ARPU, their average revenue per user, and really transforming their business so they can compete effectively with the over-the-top providers. The problem is, though, that infrastructure platforms based on enterprise-class software really cannot achieve these goals. And you have network downtime, which can cause prohibitive growth in operational costs, SLA penalties, and customer churn, and it really negates all of the business benefits that the service providers are trying to achieve through NFV. So with our Titanium Server platform, we solve these problems, and we enable service providers to realize the promise of NFV. We can deliver carrier-grade reliability at the platform level, which allows the service providers to have 6 times uptime guaranteed for their NFV infrastructure. We provide best-in-class performance through our accelerated virtual switch, which maximizes the OpEx reductions that the service providers achieve. And it's a fully pre-integrated solution. It's developed and validated using the TL9000 process, which is the telecom standard, and it's available for deployment now. It's already been deployed by many customers. It's 100% open. It's fully based on open standards, so there's no vendor lock-in, which is one of the things that service providers are trying to avoid. And as we showed a minute ago, we now have a number of validated end-to-end solutions that are available through the Titanium Cloud ecosystem, working with our industry-leading partners like our friends at Exia. So that's kind of the end of the Titanium Server overview here. And I think, Kyle, we can hand back to you, and maybe we can move to the question and answer session.
All right. Thank you, Charlie. So we've had a number of questions come in, and I encourage everyone, if you have any questions, please submit them to the control panel, and we'll try to get to them. So first one coming in I have from Michael. So is there real savings for carriers deploying NFV today?
Yeah, Kyle, let me take that one. What we're hearing from carriers is that they don't initially expect a CapEx savings because they actually are going to have to invest. And, in this case, they're going to be investing in the compute infrastructure, essentially kind of the data center type technologies. The challenge they're having, though, is that unlike, let's say, the data center providers like Amazon and Microsoft, they need to go to more of a distributed model. They need to put the data center technology out closer towards the end user. When you're doing network functions like a router, a firewall, it's pretty important that you're not carrying that traffic too far away and hairpinning it back and things like that. And so initially, what we're seeing is carriers committing to actually more of a build out where they're enabling the telco cloud out in the metro areas or out where they need it to expand this. And I think that's why you're seeing limited POCs and trials that are very successful, but they're a little slow to roll it out in a mass scale because the expense and logistics in terms of getting that data center infrastructure built out for the kind of edge cloud that they need. But what they're all saying is that there's immediate OpEx benefits. So the shift in cost or the savings in cost is in OpEx, and then over time it will come in the CapEx.
All right, great. We also had another question come in, Michael, for you. What does EM123 stand for?
Yes, EM. EM is Element Manager, and this is one of those things where when you deploy a router today or a firewall, you have a means or mechanisms of managing that device. You can tie it into a common element management system, usually based on like SNMP. The trend that we're seeing more so is still SNMP enabling or still being able to use legacy technologies, but a larger trend towards leveraging Yang and Yang modeling for to understand how something is configured as well as to manage that device. And so the complexity is not potentially having a common language to speak to every device. And so there's some startups and other solutions in there that are doing kind of one interface that allows you to speak different languages down to the element managers or devices to manage them, like for SNMP, Yang, and other type of languages. So that, yeah, it's element managers.
All right, great. Next question we had come in, Charlie, this one's for you. So in regards to the Titanium server, is it available now?
Oh yeah, it is. It's been available, gosh, almost a year now. We did our GA release in October of 2014. It's interesting. One of the challenges, one of the marketing challenges of being an embedded software company is that your software is embedded, and it's not at all obvious to the user of a system that your software is actually present in there. So it's always a struggle for us to get our customers to actually announce that they're using our software. But over the last year or so, we've had quite a few public announcements by customers that they're using Titanium Server. We've also had a number of very pleasing announcements from ecosystem partners that they ported their software over to run on the platform. So we've seen public announcements from folks like HP, Dell, Nokia recently, Altiostar in the cloud RAN space, as well as a number of recent partner announcements, such as Genband with their SBC, Firm Networks with their EPC, and actually just today, Overture Networks did an announcement that they now have their Ensemble orchestration solution up and running and ported on Titanium Server, and that was something that we did in response to a service provider opportunity. So yeah, absolutely, it's available.
All right. We had a follow-up question come in just now, and this one may be best for Michael, but Charlie, feel free to chime in. So is there a demo that shows how Ixia test tools test NFV performance on the Titanium server?
Yeah, that's a great one. This is Mike. I'll take it. We don't have that demo available publicly yet, but we are going to be very excited to show it and have it available soon. So, I'll just talk through the experience a bit, which is, because Titanium Server is built on OpenStack, when we, engaged in terms of deploying our VM on the system and configuring the networking, the experience was really quite seamless compared to working on a platform we had been previously, like the NFV solution. So the nice thing about beginning to work on a reference platform, and we're actually beginning to work on the Intel ONP platform as well, is that once you work on those platforms and you have your systems available for deploying the VM, configuring the required networking, then we initiate essentially our VM manager allows us to run our either automation or GUI to run testing. And so we've seen really good testing. And the big difference we're seeing from running a reference platform like the OPNFV moving to Titanium Server is that the Titanium Server leverages an accelerated switch, and therefore we got very good performance out of it. From a bottoms-up testing through the NICs, as well as testing top-down. And so we're actually at a point where we needed to add more NICs to the server to drive more traffic on it. And so we had some initial results, and we were intending to show a demo. However, we wanted to really kind of populate that server with as many NICs as possible to get to a much higher performance number. So that will be upcoming information that we'll be sharing publicly.
Okay, looks like we have time for really just one more question. So the next one, Michael, I'm going to send it to you, and Charlie, of course, if you have any comment on this, please chime in. So how are carriers looking to test and or verify when making changes to services in production?
Yeah, I think this is a really interesting one because, with this technology, it enables them to make changes like, spin up services on the fly, change services on the fly. And when you have that ability in production, how do you verify those changes? And so what we're seeing is more testing from the lab moving to the service activation phase or the change management phase. And this is a good example where, a lightweight test solution like IX Chariot has been a great fit because Chariot as a lightweight endpoint can be deployed essentially anywhere in the service chain and verify end-to-end, or if there's a problem, it can break down and verify segment by segment. And that's with application traffic being emulated. So again, most ways we're seeing it from our solutions is taking test capability and wrapping it and deploying it with orchestration to do verification testing once a change, either once a service has been spun up or once a service has been modified. Charlie, maybe you could comment as well.
So the only other thing that I'll add, Mike, is that one of the key questions when you start to look at what happens to a service once it's in production is how are you going to do patches and updates to that service, without introducing any downtime into the system. That's one of the key requirements that we looked at when we designed Titanium Server, was to make sure that the management platform includes the capability to do hitless patches and hitless upgrades to the VNS. And that's a feature that the service providers absolutely rely on. So in addition to being able to test the services once they're there, you've also got to be able to update them and patch them.
Okay, great. That's about all the time we have today. I want to thank everyone for attending today's webinar, Progressing NFV to Carrier-Grade Deployments, presented by Exia. Again, our presenters today were Michael Haugh, Product Marketing Director at Exia, and Charles Ashton, Senior Director of Business Development at Wind River. Thank you, Michael and Charlie.
Thanks, everyone.
Thanks very much. Thank you. Thank you. Bye.